For the third example from section 4.5, it says, find the dimensions of a closed rectangular box with a square base and a volume of 8,000 cubic centimeters that can be constructed with the least amount of material. All right, so I want to draw a box. Now, I don't care to draw the box like this in 3 dimensions. I need to know what is the cost to minimize the amount of material. So I want the minimum amount of, say, cardboard here, okay? So what I'm going to do is I'm going to take this box, cut the top of it off. Then I'm going to cut along each one of these edges right here and then fold each flap down. And I'm going to draw that picture, okay? So we have a picture that looks something like this, okay? Here's the bottom of my box. Here's each one of the sides that I cut and folded down, okay? Now, you don't have to get too fancy with these drawings. Just something that you can visualize so you can calculate stuff based off of. All right, now it talks about a closed rectangular box. So that means it had a top as well. Remember we talked about cutting off the top. Let's suppose I put the top right here. So here's the top of my box. That's the bottom of my box. All right, now, they want us to find the dimensions of this box. What is the dimension here? I don't know, so I'm going to call that dimension, I'm going to call that length X. How about right here? What is the length there? Well, I'd be tempted to use Y, except they gave us a very important word here. They said, find the dimensions of a closed rectangular box with a square base. With a square base. So that means that the length and the width of the base are the same. If that's the top, the bottom's got to match X by X as well. All right, let's see. If this length is X, wouldn't it make this length as well X for my box? And what is this right here? This was my what? Remember, that flap really went that way, right? And I bent it down. That is really my height of my box, right? And this is the side, actually, of my box. All right, so now what do they want me to do? They want me to minimize the amount of material, basically, right? So how about for the material? What is the material going to be? It's going to be cardboard. Or isn't it going to be the surface area, this plus that, plus that, plus that, plus that, plus that? So I'm going to look at my surface area, minimizing that in my box. Well, what is the area of my box here? Wouldn't it be the area at the bottom plus the area of all 4 sides plus the area at the top? Isn't that how many sheets of cardboard I would need, or how much cardboard I would need? Yeah. So what's the area at the bottom? Just a rectangle, X times X, or X squared, that's my bottom, plus the area of my top, which is also X squared, plus the area of my sides. Now, how do I find the area of the side? It's just a rectangle, so it's X times H, right? X times H. And how many sides do I have? 1, 2, 3, 4. So it's actually 4 times X times H. Make sure that makes sense in your head, okay? Area is equal to, I could call this 2x squared plus 4x times H. Now again, I have one too many variables here. So let me get rid of one of the variables, put it in terms of the other. What is the other bit of information I know right here? What do they tell me? Look back at your problem. They tell you it's to have a volume of 8,000 cubic centimeters. What is the volume of a box? It's length times width times height. They tell me the volume needs to be 8,000. What am I calling the length of this box right here? X. What am I calling the width of this box? X. And what am I calling the height of my box? H, right? So that's 8,000 is equal to x squared times h, Or I could say 8,000 over x squared is equal to h. All right, so what am I going to do now? I'm going to take this 8,000 over x squared, and I'm going to sub it in for the h right here, okay? So I have area is equal to 2x squared plus 4x, but instead of h there, I'm going to call that 8,000 over x squared. All right, well, let's multiply that 4x now. So that gives me area is equal to 2x squared plus 32,000 over x to the first. Because remember, that's over 1, and this x divides out with one of those x's. All right, now what do? I need to maximize or minimize. So what do? I take a derivative, right? So that's 4x minus 32,000 over x squared. Well, let's find my critical points. So find out where your derivative is equal to 0 and find out where it's undefined. So I'm going to take 4x minus 32,000 over x squared, my derivative, set it equal to 0. And I'm going to find where this derivative is undefined. It's going to be undefined when this denominator is equal to 0, right? Well, when does that happen? When x is 0? Can I make a box if side x is 0? No, so that doesn't make sense in this problem. How about here? Let's solve this. So I'm going to multiply both sides by x squared. So I have 4x cubed minus 32,000 is equal to 0. So I'll get 4x cubed is equal to 32,000. And if I divide by 4, I get x cubed is equal to 8,000. Take the cube root and you get x is equal to what? 20, right? So x is going to need to be 20, and then x is going to need to be 20, right? Now, what's the units we're using here? Centimeters. So I found my dimensions of the width and the length. Now I need to find my height. So I'm going to go back to this equation here. I'm going to go back to that equation. See, I need to erase something here. So I'm going to say, okay, well, h was equal to 8,000 over x squared. So h is equal to 8,000 and x needs to be 20, so I'm going to substitute in 20 here, squared. If I do this calculation, I get 20 there as well. All right, so let me list my answer. I could put 20 cm here, and that would be fine if I box in all that. Or I could say, this one's easy to write out. You could say width needs to be 20 centimeters. Length needs to be 20 centimeters. And the height needs to be 20 centimeters. And really on this one, you could have said 20 centimeters by 20 centimeters by 20 centimeters, because it doesn't matter if they switch up the height and the width and the length, because they're all the same in this case. All right, let's take a look at our next example. The top and bottom margins of a poster, that example, okay? Go ahead and read it to yourself while I erase the board. All right, so they're talking about a poster, so you're going to go ahead and draw a picture of a poster. I'm going to draw some rectangle, okay? Maybe I'll draw a poster that looks something like this. I don't know, maybe you made your width wider. Doesn't really matter, okay? Talk about the top and bottom margins of a poster, each 6 centimeters, and the side margins are each 4 centimeters. So in other words, they're talking about, we have a margin up here that's 6 centimeters. We have a margin here that's 6 centimeters. And then over on the sides, what do we have? Margins that are 4 centimeters. 4 centimeters. Then it goes on to say, if the area of the printed material of the poster is 384 square centimeters, find the dimensions of the poster with the smallest area. So they're saying this is a printed area. Think of it like a sheet of paper, okay? How you have your holes right here, your 3 holes. And then you have that red stuff, the red margins, and then you have the printable area. Well, that's what they're looking at here. Here is the printable area. So they're saying inside this box needs to be 384 square centimeters. All right, well, let's see. What am I going to do? Well, there's a couple of different ways to do this problem. Here's perhaps the easiest way. Look at your printable area right here and call this length something, like maybe X. Look at this printable area right here of this part, let's call that Y, okay? So X is from here to here, and Y is from here to here. Actually, I mean down to the black line, but there we go. You'll get the picture. All right, now what do they want me to do? They want me to find the dimensions of the poster with the smallest area. So they want the whole poster with the smallest area. They want me to minimize the area to hold the entire poster. So let's come up with area of whole poster. Or I guess we could put area of entire poster. Okay? Area of the entire poster. That's going to be area is equal to, what is this length right here then? What is this length from here to right here? Wouldn't it be X, the length of X, plus this much more, plus that much more? Or it'd be X plus 4, or X plus 8, right? What would this length be right here, from here to here? That would be all of Y right here, plus 6, or Y plus 12. So the area of my entire poster will be X plus 8 times Y plus 12. X plus 8 times Y plus 12. Make sure that makes sense to you. Don't just write down what I'm writing. By the way, you should be writing down the stuff. As I do it, you should be writing it down and taking notes. Why is that so important? How do you learn? Through your senses. Okay, so you got one sense going, sight. You have another sense going, hearing. But what about your tactile sense, the feel, and the writing out those letters? That helps you learn as well. All right, anyway, to minimize this, I'm going to need the same variable here and here, okay? So I'm going to use the other piece of information just like we keep doing. What do they say about the inside or the printable area here? It needs to be 384 square centimeters, right? So I'm going to say printable area. Printable area will be length times width, right? In this case, it'll be X times Y. But what does that area need to be? 384, right? Now solve for Y. So 384 over X is equal to Y. So what am I going to do? I'm going to take this stuff and put it in for this Y right here. So we have area is equal to X plus 8. Instead of Y, I'm going to put 384 over X plus that 12 that comes down, right? All right, you could go ahead and take your derivative here, but I'll have to use a product rule if I do that. It'll be easier probably if I multiply everything out, then take a derivative. So I'm going to multiply everything. What's x times 384 over x? 384. What's x times 12? 12x. Now what's 8 times 384 over x? Well, that's going to give me something over x, right? 8 times 4 is 32. 8 times 8 is 64. So that's 68. And 8 times 3 is what? 24. Plus 6 will be 30. So 3082. And what's 8 times 12? 96. Now, did I do that multiplication right in my head there? Was that 3082? No, it was 30 what? 72. That should be 3072. All right, anyway, I have my a function here. Let me take my derivative of it. A prime. Now, I could have added these up first, but it doesn't really matter because once you take the derivative of those constants, it's 0 anyway. What's the derivative of 12x? 12. What's the derivative of this? Negative 3072 over x squared, right? All right, let's keep going. How do I keep going? I find out where my derivative is equal to 0. So 12 minus 3072 over x squared is equal to 0. And find out where it's undefined. Well, it's going to be undefined when x is 0. And again, that doesn't make sense, right? So let's solve this. 12x squared minus 3072 is equal to 0. I'm just going to skip to it, okay? If you go ahead and solve this, I don't think anybody needs help solving that. What do you end up getting? You end up getting something like 16. Or you actually end up getting 16. So x is 16. And what would y be? Y is what? 384 over x. 384 over x. So y is equal to 384 over 16, right? And what does that give me? If I calculate it, I get what? 24? All right, so let me put this all together. What is it telling me to do? Find the dimensions of the poster with the smallest area. So dimensions of the whole poster. X is 16, but that's not my answer. What's my answer for the dimensions of this whole poster? It's going to be what? 16 plus 8, right? Or 24, it's not inches, it's centimeters, by 24 is y, so if I put in 24 plus 12, that'll give me what? 36 centimeters. So my dimensions are 24 centimeters by 36 centimeters.